In this lesson, we will learn about polymer. Did you know that all the items in these photos are made of polymers? What is a polymer? A polymer is a large molecule formed by chains of smaller molecular units. The smaller molecular unit that makes up this polymers is known as a monomer. Polymers can be classified into natural polymers and synthetic polymers. Let's look at what is natural polymers and some examples. Natural polymers are polymers that exist naturally. Examples of polymers are starch, protein, and natural rubber. Starch is made of a monomer called glucose. It is used to produce energy in our body. Protein is made of amino acid used in building cells and body tissues. Natural rubber is a polymer made from isoprene. On the other end, synthetic polymers are polymers that are man-made using chemical substances. Examples of synthetic polymers are polythene, polystyrene, perspex, and synthetic rubber. Polythene is made from a monomer called ethene. Polythene is used for making plastic products such as plastic bags and pail. Polystyrene are made of styrene and used for making packing container for electrical equipment as well as for food pack. Perspex is made from a monomer called methyl methacrylate and used for making airplane mirrors and vehicles' windows. Lastly, synthetic rubber is made from neoprene for making gloves, tires, and shoe soles. Polymerization and depolymerization. Polymers are produced through the process of polymerization. Polymerization is the process of joining the monomers through the formation of chemical bonds to produce a long-chain polymer. Depolymerization refers to the process of splitting a long-chain polymer into its monomers through chemical reactions. Observe Figure 9.5 for easier understanding. Polymerization that involves a monomer of the same type by breaking a double bond into a single bond is known as addition polymerization. Polythene is one of the example of polymers produced through the addition polymerization from its monomer, ethene. The figure below show how addition polymerization happens. Natural rubber. The milky fluid obtained from tapped rubber trees is called latex. Latex is then processed into natural rubber. These natural polymers contribute greatly to the economic growth of our country. Natural rubber is elastic, soft, cannot withstand heat, a good electrical insulator, and is not permeable to air. The action of acid and alkali on latex. In latex, rubber molecules in the form of chains are covered with a layer of protein membrane. Negative charges surround the outer surface of the membrane. This causes the rubber molecules to repel each other. Thus, latex remains in liquid form. How can latex be converted into solid form? Let's discover further. When an acid is added to the latex, positively charged hydrogen ions from the acid will neutralize the negative charges on the surface of the protein membrane. Without these negative charges, the rubber molecules will collide with one another. When the molecules collide, this will break the protein membrane and the chain of the rubber polymer is now free to coagulate to form solid lumps. Observe the flow diagram that shows coagulation of latexes when acid reacted on it. Latex left without the addition of acid will over time form solid lumps due to the action of bacteria that produces acid which neutralizes the protein membranes of rubber molecules. So how can latex be preserved in liquid form? Let's discover further. When an alkali is added to the latex, the hydroxide ions from the alkali will neutralize the hydrogen ions from the acid. Without the acid, negative charges remain on the protein membrane, and the rubber molecules repel one another and do not collide. Thus, the rubber molecules will remain in liquid form. Observe the diagram that shows how alkali prevent the latex from coagulating. Natural rubber has special characteristics. Let us carry some activities to study the properties of natural rubber. The first activity is to study the elasticity of natural rubber. Test the elasticity of natural rubber by stretching and twisting the rubber sheet. What is your observation? Natural rubber can be stretched and twisted easily. When released, it can return to its original shape. The conclusion is that natural rubber has high elasticity. In the next activity, we are going to study the effect of heat on natural rubber. What happens to the rubber piece after heating? Cut a piece of natural rubber and put it into a boiling tube containing water. Heat it slowly with a Bunsen burner. Test the elasticity of the rubber piece after it has cooled. We will observe that the rubber has melted and changed shape. In conclusion, natural rubber is not heat resistant. In other words, it is soft. This experiment is to study the action of acid and alkali on latex. What is the variables in this experiment? The manipulated variable is type of reacting chemical, the responding variable is coagulation. The constant variable is amount of reacting chemical. 10 drops of ethanoic acid and ammonia solution are added to the latex in each beaker. As a control, latex in a beaker was left aside, without adding acid or alkali. What is the observation? Latex in beaker P, where acid ethanoic is added, coagulate, while latex in beaker Q, where ammonia solution is added, does not coagulate. Latex in R, when left for a long time by itself, will coagulate. Why do latex coagulate when exposed to air? Find out the reason. It has something to do with microorganism activity. Vulcanization of rubber. The properties of natural rubber, which is soft and not resistant to heat, makes it an unsuitable material for tires of vehicles. Due to Malaysian hot weather, tires made of natural rubber will become soft and melt when exposed to hot road surfaces. So, how can the properties of natural rubber be improved to make it a suitable material for making various things? To make natural rubber harder and stronger, vulcanization can be carried out. Vulcanization can improve the properties of rubber and make it stronger. Vulcanization is a process of heating rubber with sulfur. During vulcanization, sulfur atoms are added to the chain of natural rubber polymer molecules. The rubber obtained through this process is called vulcanized rubber. A bit of history. Charles Goodyear is the founder of vulcanization process in 1839. Vulcanization is carried out by heating a mixture of 3% sulfur and natural rubber. We must appreciate scientists such as Charles Goodyear. The molecular structure of vulcanized rubber has a bond between each chain of rubber polymer. This, however, cannot be seen in natural rubber. This is due to the added sulfur atoms that produces crosslinks between the rubber polymer chains. Can you identify the cross in the molecule structure? When a force is applied, it is difficult for the chain of vulcanized rubber polymer to slide over each other. When heat is applied, the structure of vulcanized rubber molecules is difficult to break. Thus, the vulcanized rubber is harder and has high resistance to heat. It is harder and has high resistance to heat. There are 6 special qualities of vulcanized rubber. Firstly, it is hard and more elastic. Secondly, it is a good electrical insulator and difficult to be oxidized in air. Vulcanized rubber does not react with acid and alkali. It is also not permeable to liquid and air. Lastly, it is resistant to heat. What are vulcanized rubber used for? Vulcanized rubber is suitable to make tires, rubber gloves and shoe soles. Can you think of other usage of vulcanized rubber? The latest rubber-based technology. Rubber is one of the major commodities of Malaysia. The rubber industry has improved the economy of the country. Research and development on rubber is carried out by the Malaysian Rubber Board. This research and development needs to be continued so that the rubber industry continues to grow in our country. Some discoveries have been made using the special properties of rubber in the manufacturing and construction field. What are these new technologies? In road construction, cup-lump modified asphalt CMA acts as the concrete asphalt for the pavement to last longer, resist heat, reduce noise and road cracks. In the creative industry, latex is used to make color paint for visual art. In modern LRT system, the rail pad of rubber is placed between the railway and the train's engine to reduce vibration and sound. This improved the ride quality of the train. What is the future of our rubber industry? Find out more on the latest rubber-based technology. That's all. Thank you for listening. We hope that you enjoy this presentation.